All right, everybody. Good morning, and welcome to the MUP transition from EnergyPro Residential version 5 to non-residential version 7. My name is Nolan Stevens, and I'm a program associate on the multifamily upgrade program technical team. I'm here today with Jessica Nunez, a program associate, and Matt Jones, the program technical manager. My colleagues and I work for TRC and implement the multifamily upgrade program on behalf of PG&E. If you have any questions, please enter them into the questions bar. We will stop periodically for questions and then again at the end of the webinar. The session is being recorded and will be made available along with the slide deck to you after the webinar. I have a few reminders today before we get started. First off, every year raters need to become a participating rater. And to do this, raters must fill out the program agreement and meet insurance requirements for the program. So far, we only have one participating rater in the program, and we would like all of you to join the program. We cannot reserve incentives for a project until the rater has become an approved rater. Secondly, you have until March 31st to submit applications to still be eligible for an early assessment incentive payment. The early assessment payment will be 25% of the total assessment incentive. Your project must also complete the full assessment review process, including the TRC review within 90 days of application. The early incentive will be paid at the incentive reservation. And with that, I'm going to turn it over to Jessica.
Thanks for getting us set up, Nolan. So today I'm going to be talking about the non-res transition, specifically a little bit about the motivation for this, highlight some of the main differences between the two softwares and what you're going to be expecting, like results-wise, the difference in savings. And then I'm going to do a walkthrough of the procedure for transitioning these models to show you how it's done and also to provide some insight to you guys for what we're looking for when we do our assessment reviews for the program. So motivation for this transition, it came down to us from the CPUC that we needed to model in non-res because of the simulation engine. So residential software version 5 uses CalRes, while non-res uses DOE 2.1. 5 and 7 both use this engine, but it's not the latest software. So DOE 2.2 is the latest software, and it's more likely that EnergyPro 7 as opposed to EnergyPro 5 is going to be updated in the future. So that's why we're also transitioning to EnergyPro 7. So within non-res software, there's some like technical differences. So as far as model customization, you could take credit for larger lighting savings, appliances. There's a lot more flexibility in that. So yeah. So some of the main differences are in residential version 5, you could do all your measures in the alternatives tabs, while in non-res version 7, you could do a lot of those measures the same way, but you're going to have to do a two-model approach for certain measures such as indoor and outdoor lighting and appliances. And the other major difference is how you input those into the model. So in residential version 5, you could use the HERS tab for all your lighting, all your appliances, but in non-res, we're going to have to model an LPD, exterior uses, and process heat for all of those items in the model. So before I get started, I'm going to do my best to really point to everywhere on the screen where I am making any changes to a model. But if I make any, if you don't know what I'm doing, a lot of times I'm like doing it just for my keyboard, Control H, replace things. It's also a neat little tip to speed the process along when you're updating models that some people don't know about. So yeah, so I'm going to be switching between an EnergyPro 5 model, EnergyPro 7 model, and the TRC calculator, which all of you should have seen or should have received prior to this. So with that, I'm going to go ahead and get started. So I have a model already opened up right here in EnergyPro 5, and I made a copy of this model and have it open also in EnergyPro 7. So what we're going to do is just walk through step by step of how you complete the transition. I'm aware most of the raters, you won't be transitioning an existing model to EnergyPro 7, but this will also highlight for you some of the differences between the two softwares, and you could have insight into what we're doing when you submit to us EnergyPro 5 models. So you could continue submitting to us EnergyPro 5 residential models for the rest of this year, but starting next year, you will be required to submit them all to us in non-res version 7. And this year, we will be converting all the models and reporting savings to PG&E based on the non-residential calculations. So the first main difference here is we're in our residential version 5 model. And we see at the zone levels, we're in multifamily, building area, office. The lighting occupancy doesn't matter here, but the occupancy is multifamily, which only runs residential calculations. The calculation is over here, and you're selecting res performance. So in EnergyPro 7, in order to switch to calculation engine, we're just going to come over here. We see it's multifamily, building area, office. We're going to want to change that. And since we have multiple zones, instead of going in to every single one and changing it manually, we could use this replace wizard, and you go to occupant and you switch that from whatever your existing is to your proposed, and it will update all of them. So you can see now that all of them are updated. Now we want to do the same thing for the lighting occupancy. So that's in here. You want to switch that from building area office to building area multifamily. And the next step is all of these different occupancies have associated load assumptions with them. So this is still existing from the multifamily occupancy. So you're going to want to update that by updating your load assumptions globally. So now you have the assumptions that are required to accurately run the non-residential simulation engine. So we're going to be updating a few other things so to mimic multifamily assumptions, even though we're running a non-residential model, but those load assumptions we do want to change in order for the algorithm to run properly. So then you're going to come to calculations, unselect res performance, select non-res performance, and now you're pretty much all set up to run the new calculation. So I'll stop right now. Are there any questions so far?
No, there's no questions so far.
All right, cool. So I'm going to move on to, actually, I see a question coming in.
We have one thing coming in, yeah. Slow down and explain the load assumptions. The load assumptions.
Okay, yeah. So going back to the, so the question is there was some questions about the load assumptions. So basically when you're running a residential calculation, you have some assumptions made about the performance of the building. So you have an assumption about occupant density, sensible heat per occupant, and we don't want to run it with the assumptions of residential. We want to run it with assumptions of high-rise residential or non-res. So I'm going to open up the version 5 residential calculation. You see that the load assumptions here are basically the only difference is the feet squared per occupant. The DOE 2.1 algorithm in the non-res calculation is optimized to run with an occupancy of density of 140 to 260 feet squared per occupant. Outside of that, it doesn't perform the way it should. So that's why we have to make sure we update that.
We got a couple more coming in as well. The lighting change, like a little brief recap of that.
So I haven't really gone into detail about the lighting change. That's actually next on my list. So I'll go ahead and get into that right now. So in EnergyPro Residential, you input all of your lights here in the HERS tab. So you have a location, a type of light, and a number of lights, and this is for one, basically, unit. And instead of inputting that here, because the non-residential software doesn't take this as an input, we're going to create an LPD, or a lighting power density. And in the non-residential module, it will be input at the zone level lighting. And instead of, you're going to change this right here to user input LPD. So there's no quick way to do this. You have to go to every zone and select this. And the way you calculate this is, we have a spreadsheet here that you've all been provided with, and this is the lighting tab. So our calculator will exactly mimic the inputs of the residential model. So raters are welcome to create their own calculators if they could do detailed calculations as far as the location of lights in the building or in the unit, ballast, including ballast factors or fixture wattages. And we're happy to vet those calculators, and they would need to be submitted with the test-in package in order for us to accept them. But if you don't have that detailed calculator developed just yet, you could use our calculator and it will give you the exact same results as residential. So it works. Basically, you input the existing count of lights here in this row, and it corresponds to a location and a type of bulb. And you input the proposed. So instead of going into the alternatives tab in the residential module and selecting here, all my appliances will be high efficacy with on-off switch, you put your proposed. So you have the option of changing only a certain light, so you don't have to do all of them. You could say, oh, this one has 2 incandescents, but I'm going to leave it as 2. So proposed would be 2, and I'm only updating this one. So existing and proposed, but in this case, we're going to want to update all of them. So for each section, say here in the hall entry, I have existing 3 light bulbs, 2 incandescent and 1 high efficacy. I'm going to propose that they're all high efficacy. And you also have the ability to change the controls. So for each, again, corresponding light type and section, you input a control value. So if it's an on-off switch, you input 1. If it's dimming, 0.9, and occupant sensor, 0.8. And all these calculations come from the HERS technical manual, and that's how we developed this calculator. And the way you input these values into the model is you have this watts per square foot, existing and proposed. So you have to do a 2-model approach now. You can't just do the alternatives tab. So in the first model, you'll put the existing. So we'll come in here. And where this goes is you could come in here if you have one zone and put the value here. But since we have multiple zones, we want to replace them all at once. And we could change the ones that are 0 to 0.56. And now we see that all of those have that value. Any questions on this?
We had one, I believe it was in the calculator. What is PAM? It was 2 tables down low.
Okay, so I have a question coming in. It says, what is PAM control? Huh. Its reference is just a name of one of the variables in the HERS technical manual, which is how we developed this calculator. I could go ahead and look into that after, but I don't remember exactly what it stands for right now. Sorry about that.
Yeah, hey everybody. I also don't remember exactly what it stands for, but it's a factor to adjust for controls on the lighting and also to adjust for the type of lighting. So it's basically a multiplier that's applied to reduce the overall energy use if you have, say, high efficacy fixtures or controls.
Thanks, Matt. So coming back now to the HERS tab, we showed you how indoor lighting is affected. The other change is with appliances. So here you input appliances for your refrigerator, your dishwasher, and one thing with the dishwashers is you are required to input a dishwasher. In non-residential software, you won't be required to do that. And same with the washers and the dryers. You aren't allowed to input any efficiency values for them. So with the new non-res software and our calculator, you'll be able to calculate more precisely the energy use for this equipment. And currently, the way you model an upgrade for that in the residential model is with appliances right here. You input your proposed and your proposed for dishwasher as well. And in non-residential, instead of doing that, what we do is we come here, we built this into our calculator. So you input all the information you would input into the HERS tab, you input here for your refrigerator existing and proposed, dishwasher existing and proposed. But our clothes washers and dryers it has a little bit more customization, like I guess you could customize it a little bit better. So you select here if it's common area washer and dryers or if they're in unit, and this will change whether the energy use for the equipment is placed into the units as a watts per square foot or as an exterior usage so that there are no interactive effects. So you also select the dryer fuel and the water heater fuel as you do in the HERS tab. But the difference is you're allowed to input a modified energy factor. So based on whether you have a top load or a front load. And then similarly, you could input a proposed top load or front load and a proposed modified energy factor. And if you have gas for either of the clothes washer DHW or the dryer, this will by default have to go into exterior uses. But if you have electric and it's in the unit, it will go into the unit. And I'll show you how that works right now. So in this case, we have washers and dryers outside of the unit. So it's a common laundry unit. So you're going to use the process load for inside the units just for the refrigerators and dishwashers, and that's right here. So it's 0.212 watts per square foot. So in this EnergyPro 7 model, you come into the room level, and where this is going to go is process sensible heat. So the way you update this is you could either come in here and say 0.212, but since we have multiple floors or multiple rooms, I'll just do this to replace them all at once. It's a receptacle process, and you come down to the process sensible heat. And now that is updated for all of the rooms, as you can see. And for the laundry equipment, since it's in the common areas, we're going to put it in exterior uses. And there will always be electric usage for the mechanical energy. And then since they had gas washers and dryers, there'll also be gas usage. So the schedule you're going to want for this is California low-rise process. You just look for that here. It's not right. And same thing here. And the values for this are back in the calculator. So there's lots of different inputs here. The about section of this calculator will tell you exactly which ones you're supposed to use depending on the case of where all of your equipment is located. So your exterior usage for your laundry equipment is right here, your watts and your BTUs per hour. So we have 425 watts and 16,389 BTUs per hour. Okay, so that's it for, well, actually one more step on the appliances is also that instead of using the alternatives tab, you're gonna have to do a two-model approach for this as well. So similarly to with your lighting, you'll come back and when you build a second model for the proposed case, and you'll input instead of this value and these two values, you'll come down here and do the corresponding proposed values. So do I have any questions on this section for the appliances?
Looking good, Jessica.
Cool. So our next step will be to come in to update the schedules. So in the residential model, you don't have to input any schedules. It's just default schedules. But for the non-residential model here, which I just accidentally, okay, it's here. I thought I deleted it. I was having a mild panic attack right there, but it's back. So we'll have to define schedules in here. And the schedules we're gonna wanna change are cooling, heating, and process, first of all. So since we have multiple zones, again, you'll come in here and do this here. And you're gonna want California low-rise cooling. California low-rise heating. And California low-rise process. The final schedule that we're going to change is a custom schedule for the multifamily upgrade program, and that's lighting. So I'm going to come in here and define it one time with you guys, and then I'm going to update it for all of the zones. So what I usually do is I start with the 90.1 multifamily lighting because it's most similar to that. Make a copy. Label it like multifamily upgrade program. And the schedule is, the way you'll define it is 19 in the first hour. All the details of what the inputs are in the calculator right here. I'm just going to put it in from memory. And you copy and paste this over to each. And this could get a little tedious if you have to define it every time, but you don't. So you just export this now to your default library, and that schedule will be available for you whenever you want to use it. So now I'm going to replace all again, so all of these zones have the new lighting schedule. Okay, any questions about those schedules?
So yes, we do have some questions. Can you please explain the schedule for the non-residential module and not in the res module?
Yeah, so the question was, why do we have to change the schedules in the non-residential module and not in the residential module? So in the residential module, we're running a residential calculation, and the schedules they take, they're automatically running California low-rise schedules. So when we come over here to non-residential, it's not going to default to take a residential schedule, so we have to input that in for our major uses. Do you have any more questions, Nolan?
Can you just maybe give a brief example of the washers and dryers being inside the tenant's units? I know that it's going back one step.
Yeah, no problem. So we have a request to explain washers and dryers being in units. So I'm going to come back to the calculator, and here what I would do here is say instead of common area, I would put they're in the dwelling units. And you see these values just became higher. So instead of using this value, I would use this value in the process load watts per square foot, because this now includes the laundry electricity usage that's in the units. So basically, this value right here will be a little bit higher. But if there's still gas dryers, there's no way for us to input that in the units, so it will be put in right here. So you won't get the interactive effects from that. All right. Any more, Nolan?
Nope, you're good to go.
Hey, Jessica, this is Matt Jones here. Could you just go through that one more time? I still had a little hard time following it, and I think it might be useful. So kind of go through a common area versus in unit, and what selections you'd make, and probably even what the tool is assuming or doing when you make those selections.
Okay, great. So I'll go into more detail about the tool right now. So refrigerators and dishwashers always in the units. Here, if I have a dwelling unit appliance, we're assuming each washer and dryer is being used a lot more, or a lot less, because it's only one person using it. Whereas if we have 4 washers and dryers in the common area, there's a lot more usage per unit. So that's what switching this tab does. Modifying the energy factor is basically an efficiency rating. So higher is better. So there's more usage when you toggle that. And the dryer fuel, if we change this to electricity, we'll see that this value, the process load of watts per square foot, increases when it's in the dwelling unit. If it's not in the dwelling unit, it's in the common area, and we see that this value right here, C, exterior uses watts, we'll see it change pretty significantly. If it's currently in the common area, if it goes to dwelling unit, it decreases, and this one increases because it switched to the units. So in summary of that all, if you have laundry equipment in the units and it's all electric, that whole, the heat from that equipment will all be entered right here, and the calculator will calculate that for you. If they're all in common areas, everything will be input in exterior uses, so electricity and gas. If they're in the units, but you have gas dryers, the electricity usage from the laundry equipment will be input here in the process equipment, and the gas usage from that equipment will be entered in exterior uses, because there's no way for us to input it at the room level. Any more questions on that?
Thanks. I think that was really good. I'll just jump in and address Ben Thompson's question. He was asking if we can add water factor to the calculator tool. And Ben, I'll check in with you after this call. If we add that, I don't think it will make any differences to the model inputs that you use here, but I could see that it might be useful for other things. And secondly, I just want to point out to everyone that in the email that we sent, there's a link to this tool, but after the webinar, we will attach the tool, or we'll attach the tool to an email that we send everybody, so everyone will have it at the top of their email.
Okay, thanks, Matt. So I'm going to go ahead and keep moving forward. The next step is defining the dwelling unit. So opening up EnergyPro 5, you define the dwelling units at the room level. So you come into the occupant tab, and all you can define right here is number of kitchens and number of bedrooms. So 36 kitchens, 36 bedrooms means that there are 36 one-bedroom units. And similarly over here, 38 one-bedroom units. So in EnergyPro 7, you come in, and the first floor, you come to the dwelling units tab, and we know that there's 36 one-bedroom units. So we're going to assume for this case that all the units are the same. There's just 36 one-bedrooms. And we have to find out the area, because the total area is 21,168. that means there's 588 square feet per unit, and you just give this unit a name, dwelling unit 1. If there were multiple bedroom types, say I had a mix of 18 one-bedrooms and 18 two-bedrooms, you could define multiple unit types. So DU2, and I could say that there's 2 bedrooms. So I could go back and say 18 and 18, and they're both the same size, but one's a 1-bedroom, one's a 2-bedroom. That's how you would do that. So in this case, that's not the case. We just have 36 1-bedrooms. And also from the HERS tab, you could come down and replicate these things. There's no washers and dryers in the units. We could check our EnergyPro 5 model, see that there's electric range, and do the same thing on each floor. So this is the same unit type, except there's 38 on the 2nd floor. And then for common areas that are modeled in here, what you're going to want to do is you just have to input the area and you put 0 bedrooms. It's because there's no people like inhabiting it, but there's you need to get the area in there. So just label this whatever it is, lounge and lobby. And that's how you define these items. And the biggest impact these items have defining this is in the DHW usage. So if your DHW usage is looking a little weird, just come back and check, make sure you define these areas and unit types. Do I have any questions on this topic?
No, not on that topic.
Okay, cool. So let's see. Next item to go to is our HVAC systems. So in EnergyPro 5 and EnergyPro 7, you define them basically the same way, but there's some special items you want to pay attention to in non-residential software. So our controls, we really want to make sure that our fan operation is set to what it actually is in real life. So I know in EnergyPro 5 or in the residential module, this doesn't make much of a difference. It makes a huge difference in EnergyPro 7 non-residential. Second thing is heating and cooling outputs. In EnergyPro 5 residential, you could input 1 or you could input like 1,000,000 and it wouldn't make a difference. You would just have the actual, like it would auto size the load for you. EnergyPro 7, it's not the case. So you need to be sure you're inputting, if you don't have the exact value, a reasonable estimate. Next item here is the fans. So in the design power, you don't want to actually input the rated horsepower because the fans, as I said, they don't auto size like they do for you in EnergyPro 5. So what you want to do is you want to put in a design power based on our calculator as well. So our calculator has a fan horsepower tab. So what you basically do is you input the output of the cooling system, the total output, and based on some standard like industry assumptions of CFM per ton, static pressure, and efficiency, we use 0.97 as a default because that's what EnergyPro uses. If you have some insight onto the fan efficiency, you could update that here. And we put a design fan horsepower. So in this case, we have 11,500 as your output, and the rated fan horsepower is 0.5. Instead of 0.5, we're going to want to input this, so 0.03. I'm going to maybe change something else in it. So that's what you want to change right there. Do I have any questions about this?
No, but I'm going to bring up one from the previous section. Would you update the lounge and lobby with the new inputs?
That's a great question. So what we usually do, Oh, so the question is, would I update the lounge and the lobby with the new inputs? So what we're having people do generally in the multifamily upgrade program right now is in the HERS tab, you take an average of all the common area spaces and distribute those that lighting equipment through the units. So the lounge and the lobby lighting is included in this HERS tab. So now you actually do want to, because the inputs are being accounted for in the HERS tab, and we just want to distribute it through all the spaces in the model.
Okay, Jessica. What about the washers and dryers beyond just the lighting?
Yeah, so there you wouldn't want to input the loads for that. So like in this level, you wouldn't need to input this value. It's mostly in the tenant occupied spaces where you have the appliances being used.
Okay, great, Jessica. Thank you. Yeah, we're good.
But so one note.
Again, I have a question for you, Jessica.
Yeah.
So if we have common area washer and dryer, and it's in a conditioned common space, shouldn't we be entering the watts per square foot in the lobby area in that case, or whatever, whatever zone is the common space where the equipment is?
Yeah, that is a good point. So if it is an attached, like it's inside a conditioned space, you do want to put it in wherever it belongs. But in the case, if it's like a kind of off-site laundry equipment or like detached or in an unconditioned area, that's what the exterior uses is for.
Okay, and it looks like we have one more question. The question is, in common areas, what happens if we don't define dwelling units?
So you'll get an error. Or the question is, what happens if we don't define dwelling units in common areas? Mostly you'll get an error on the conditioned floor area saying you have this system here, you have an area defined, but then it's not matching over here. So you have to come in and define it so that this matches these two areas. Yeah, so any other questions before I move on?
No other questions have come in.
Okay, so the next item is heating hot water. So in EnergyPro version 5, you define your domestic hot water system, and say you have hydronic heating, you would just come into the HVAC, define hydronic, and if you didn't define a boiler in heating hot water, it would automatically draw that water from your DHW. In EnergyPro 7, that's not the case. You either need to replicate that DHW boiler, just copy it and do the same thing right here, or you can come down to the HVAC system and there's a item right here, hydronic space heating, select DHW boiler provides heat. So you just need to specify that additional item. And one other item regarding DHW systems that's different is when you open up the EnergyPro 5 model and EnergyPro 7, as I did, you need, most of the items will just copy straight over from EnergyPro 5, but DHW systems, that's not always the case. So this is the EnergyPro 5 model. You open it and it's a multifamily central system and there's no pump control. So the control is none. When I open that up in 7, it defaults not to no control, but to no loops or central system pumps. So you want to come in here and make sure you select the correct pump control. Yeah, so that's pretty much the whole procedure. There's just a couple items that are what was I gonna say? So that's basically, that's the whole procedure for transitioning the models. A couple more items just to look out for are, like I said, the DHW system. Make sure that's there. make sure you size all of your equipment or input the rated size except for the fans. And one more item I wanted to hit on that we didn't really used to look out for in assessment reviews, but with the non-residential software it matters, is the way you multiply your HVAC systems. So even though the first floor and the second floor have residential PTAC, it's not ducted, so you could maybe be tempted to say, okay, there's 74 right here, and let's just put them all under one system multiplied. This could just come in here. We don't want you to do that. That has a significant impact on your results. So this is wrong. What you always want to make sure is just, at least for each floor, if these areas can't be controlled by the same thermostat, theoretically, or don't put them under the same HVAC system. You have to make sure they're separated. EnergyPro actually recommends, if you have less than 20 units, that you create a specific zone for each unit and separate the HVAC systems by at least per floor. So we don't expect a separate zone per unit, at least a zone per floor, and separate the HVAC systems in a corresponding kind of way. Any more questions?
No more questions about the transition. This webinar will be posted on the MUP YouTube channel, and in an email after the webinar, we'll send a link to this webinar along with the tool and the slide deck. But I see no more questions coming in at this point, so I think we're all good to go.
All right. So thank you, guys. It's not on presentation mode.
Thank you very much for joining us today.
Thanks, guys.